Okay, so for the next question here, we're going to factor this equation in quadratic form. So let's look at the pattern. Just like if you have a quadratic equation, right? You have a constant, a variable, and then that variable squared. You have the same thing here, a constant, e to the x, and e to the x squared. So we can factor that in quadratic form. And instead of saying x and x here, instead we say e to the x and e to the x, so that they multiply to e to the 2x. And the rest, you need two numbers that multiply to -2, but add to -1, and that's -2 and +1. Next, you have to set each one of these equal to 0 and solve. So here I get e to the x equals 2. And when I take the ln of both sides, I get x equals ln of 2. Here, e to the x equals -1, and taking the ln of both sides gives me x equals ln of -1. But since that doesn't exist, I cross it out, so I only have x equals ln of 2. The next one, I add 3 to both sides. So I get 40e 0.6x is equal to 240. Divide by 40, and I get that e to the 0.6x is 6. Taking the ln of both sides, 0.6x is ln of 6. So x is ln of 6 over 0.6. This one, however, we do want to plug into the calculator because generally we don't want to leave a decimal inside a fraction. So it will be 2.9863. Okay, next, for this problem, we have to first condense this left side. So we'll get ln 7x plus 3 over x plus 1 equals ln 2x. Setting the inside equal to each other. Now we're going to cross multiply. X plus 1 times 2x equal to 7x plus 3. And I'll just go over here. When I distribute, I get 2x squared plus 2x equal to 7x plus 3. Move everything to the same side. 2x squared minus 5x minus 3 equal to 0. 2x, x. And if I factor this, I'll get -3 there and +1 here. So that I get -6 plus 5, which is -5, plus 1, which is -5, and that all that is equal to 0. So 2x plus 1 equals 0, x minus 3 equals 0, 2x equals -1, x equals -1/2, and here x equals 3. But when you look here, you see that x equals -1/2 will give an ln of a negative number, so that doesn't work. So x equals 3 is my only answer. Okay, next. What I have here is 27 to the power of 3 over 2, and this is what we usually go over in Algebra 1 and Algebra 2, but we're just doing a recap right now. Remember that fractional roots can be written as, fractional exponents can be written as roots. So this can be written as the square root of 27 cubed, which is a little overwhelming, or root 27 cubed on the outside. So if I just take root 27, that's 3 root 3 cubed. And that gives me, right, so essentially I have 3 root 3, 3 root 3, 3 root 3. And these 3's together is 27. And then here I have root 3 times root 3, that's times another 3. And that lone root 3 stays. So finally, I get 81 root 3. For this next one, I have a square root of 12 to the power of 5. And root 12 is actually 2 root 3 to the power of 5. So again, right, this 5 the exponent of 5 belongs to the 2 and the 3. So 2 to the power of 5 times root 3 to the power of 5 is essentially what I have here. 2 to the power of 5 is 32. And what's root 3 to the power of 5? That's 5 of these, right? So it's 3 times 3, 9 root 3. Okay, so finally, of course, we can multiply the 32 and the 9, and we get 288 root 3.